Hello everyone, welcome back. So in today's lecture we are going to cover set matrix 0, how to write it in a more optimized manner. Okay, so in the previous video we covered brute force approach in which we wrote this code, right? And the time complexity was n cube. So in this, just a quick recap. In this, we were iterating in the matrix, right? We were iterating in the matrix, and wherever we found a zero, what were we doing was like we were marking that cell with minus 99999, right? And then again, after marking it, we again were iterating through the matrix, and then we were mark, marking it as zero, right? So now the time complexity of this approach was n to the power cube, right? But this will not impress the interviewer, right? So in this video, we are going to optimize the solution and bring the time complexity from n to the power cube to n to the power square. Okay. Now, since it's a matrix n to the power square, it's the least which we can do. Okay. Now, let's take an example. Let's say this is our matrix. Okay. So in this matrix, we can see that here there's a zero, here there's a zero, and here there's a zero. That means if this is a zero, then we have to convert this whole row and this whole column into zero, right? And here, when we encounter a zero again, here also the same, we will have to convert this row and this column into the zero. Now again, see this carefully. Here, when we encounter this zero, we will have to convert this column again and this row again, right? So here we can see that we are repeating for this column, right? We are repeating for this column. Now here in this video, we are going to find an approach which will ensure that we don't traverse in a column or row more than once. Okay, what we can do is when this is given, we know what we will do is we will create a separate space. Okay, and here we will mark those column or row which wherever we encounter a zero. Let's go through this approach. Okay, now what will be the size of this? It will be the size of column, right? Column size. What will be the size of this? This will be size of number of rows, right? Now what we will do is, let's see here, we will, okay, at first, what will be the initial values of these metrics? Okay, let's say the initial values are 0. Okay, now when we come, now let's iterate in the matrix. Got it? Here, did we encounter a 0? No. So it's okay. Did we encounter a 0 here? No, it's okay. Now, when we come here, we see here's a 0. What we will do is, we know that whether here a 0 is present or not present, but we have to convert this whole column into 0, right? So what we will do is, we will mark this as 1 and we will mark this as 1 as well, right? Now again we will traverse 1, no, 1, no, 1, 1. Again we encounter a 0, right? Now again for this whole column we will mark it as 1. Here also we will mark it as 1, okay? 1, 1, 1. Here also it's 0, correct? Again we will mark it as 1. We will see it's already 1, right? Now again for here we will mark it as 1. Now again 1, 1, 1, and we are done. Okay. Now what will our code look like? Let's write our code. Okay. Firstly, we will prepare the extra space which we are taking, right? Let's say I am taking as row mark. Okay. And then I am taking call mark. Okay. Now what we will do is we will write the for loop so that we can append 0, the initial values, to this marking matrices. Okay. So here what I am doing, I'm going through the len matrix. Okay, now that I'm appending 0, the initial values. Okay, now here again I'll run the for loop, and then I will append 0 to the column matrix, right? Okay, now what will be our next step? Our next step will be that we will iterate into our original matrix, right? Now let's do that. For row in range len matrix. Okay, that's how we write a for loop, right? For column. Okay, now here what we will do, if we will check if we are encountering a 0 or not, correct? We will check if matrix row and column is equals to 0, then what we will do, as I said, if we encounter a 0 anywhere, we will mark that column and that row as 1, right? That's what we will do here. Row mark row is equals to 1, and call mark column is equals to 1. That's what we are doing. And here we are done. Okay, here we are done. Now what we have to do now is we will again iterate in the loop, iterate in the matrix, and now we will just check our roll mark and call mark, that if we find a 1 anywhere, we will just mark that matrix row and column as 0. Let's traverse once again. Right now, I'll just check if either of them, let's say here only one is present here, right? Only one is here also, I'll have to mark it as 0. Mark it as 0, correct? So I'll check if row mark row is equals to 1, or if either of them is marked as 1, I'll have to change that row and column to 0, correct? If either of them is marked as 1, I will have to change it to 0, and then we will simply return the matrix, and here we are done with our code. Okay, now how is it working? Okay, and here we are done with the code. Now let's go through the code once properly. So here I have written the optimal solution, which is for n square time complexity, right? How is it n square time complexity? As we can see here, we are traversing for n square, right? This is nested loop, loop inside loop, and it's only for n square, correct? So here I have created two extra spaces for row and column marking. Then here I am appending 0, the initial values, to both of the marking matrices. Okay. Now here I am going through the matrix, iterating through it, and I am marking the row and column as 1 wherever I am finding 0. In this next iteration, what I am doing is, again I am going through the matrix, and if either row or column mark is 1, what I am doing is I am marking that row and column cell as 0. Okay, so this is how the optimized code looks like. Let me know if you have any questions or concern regarding this solution. I'll be ready to help you out. If you like this video, please like, share, and subscribe. Thank you.